Hello friends, so this is the 8th question related to maximum power transfer theorem which we are going to discuss. So here we have is this circuit which is connected in this fashion, and here it has been given that the maximum power which is transferred to this load, it is given by 12 milliwatt. Okay, this is given, and it has been asked to find the value of these unknown resistors. These are all equal. So again we have to use the Thevenin theorem approach. Okay, so first we have to find VTH, then RTH. So we have to find the Thevenin equivalent circuit across the load resistance by opening it, removing it completely. So we have to redraw the circuit. So it is okay, this 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 is VTH, this is 1 volt, this is 12 volt, this is 3 volt, and these are all equal to R. Now if you see, the voltage in between these 2 points is VTH, between this and ground. It means here also the potential, it is equal to VTH, okay, because there is no resistor in between. So we can write a nodal equation from this point. Here it will be the currents flowing, let's say it is like this. Okay, so it will be VTH minus ground minus 0. Okay, or we can say in this point here it is 1 volt, 2 volt and 3 volt. In between these 2 points, VTH minus 1 by R plus VTH minus 2 by R plus VTH minus 3 by R is equal to 0. Okay, for these currents, let's name it as I1, I2 and I3. I1 plus I2 plus I3, it is equal to 0. I1 is VTH minus 1 by R, I2 is VTH minus 2 by R, I3 is VTH minus 3 by R. So here if we take the LCM, it will be R. So it is VTH minus 1 plus VTH minus 2 plus VTH minus 3 is equal to 0. That implies 3 VTH minus 6 is equal to 0. R goes to the numerator, gets multiplied with 0, so result is 0. That implies VTH is equal to 6 by 3, which is equal to 2 volt. VTH is equal to 2 volt. Okay, VTH is equal to 2 volt. So we have got VTH. Now we have to find RTH. So VTH is equal to 2 volt, Thevenin voltage we have calculated. Now we have to find RTH. So for that we have to deactivate all the independent sources. In this case we have 3 independent voltage sources, 1 volt, 2 volt and 3 volt. We have to short circuit them. So in that case the circuit, it will become something like this. Okay, and then this. Okay. So we can redraw the circuit as something like this, where it will be okay, and this, okay, like this. Okay, this is the whole thing. So here basically RTH, all these things, they are in parallel. RTH is R parallel R. So it is RTH is equal to R parallel with R parallel with R. So it is equal to R by 3. Okay. So RTH is equal to R by 3. Now it has been given that the maximum power transferred to the load RL is equal to 12 millivolt. So we know that as per the statement of maximum power transfer theorem, maximum power is transferred to the load if the value of load resistance is equal to the Thevenin resistance. So in this case, RL should be equal to RTH, which is equal to R by 3. Okay. We know PRL max, it is given by VTH square by 4 RTH. That value is given as 12 milliwatt, or we can say 12 by 1000 watt. So if we substitute VTH and RTH, we will get, that implies VTH square means 2 square by 4 into R by 3 is equal to 12 by 1000. Okay, that implies R is equal to 4 into 2 square 4 into 1000 by into 3, because this 3 goes to the numerator, by 3 divided by 4 into 12. Okay, so 4 gets cancelled, 3 12, this is 4, 4 this is 250. So the result is the value of R is equal to 250 ohms. Okay, so it has been asked to find R, this value of these 3 equal resistors. So R is equal to 250 ohm. So it was a simple application of maximum power transfer theorem in an indirect manner to find the value of the resistors, because Thevenin resistance we calculated R by 3, and as per the statement of maximum power transfer theorem, for maximum power transfer, load resistance should be equal to the Thevenin resistor. We were given with this 12 millivolt value, PRL max, so we just substituted the value and we got the value of R, which is 250 ohm. Okay, so here it was an interesting question related to the application of maximum power transfer theorem and Thevenin theorem as well. Okay.